Okay, here is what we need to go through is open the last week file, go to working week 6, and then you can drag and drop the Jeju protected step 2. If you don't have it, you can download it from the data. And if you have it, you can just use it. And this is actually from the week 6. So yeah, you must have one of those. And when you open it, you can see it asks which item to add, because last time when we were working, I created one called output, and then there were requests to do it again. So I repeated once again, and then saved it as step 2 underscore new. So this one file, Jeju protected step 2, has 2 layers. So the thing is, why can you have 2 different layers, entirely 2 different layers? This doesn't happen with a shape file. This only happens with I mean, not only, this happens with database. So it means geopackage or GPKG file itself is a database, not just a file. So let's open step 2 new, and we will add it. Everyone can see this screen, right? It's all visible, right? Can you confirm it? Hello, everyone. Yes, that's great. Okay. Okay, now we are going to have a background OpenStreetMap as well. Drag and drop and open it. Let's review what we have done so far. We could be able to change the color. So in this case, we could join in, we can zoom in, and there is no way that we can see what we have what we have in the second layer, right? Because the Jeju protected step 2, which is the upper layer, entirely completely blocked the OpenStreetMap. So we don't know what happens, what kind of data we are missing from the OpenStreetMap, right? So OpenStreetMap is not very useful here. So what we can do is double-click Jeju protected step 2, and then go to symbology, and then change the opacity to say 50%. Then okay. Now we can see a more transparent layer. Okay, let's do this on your own machine, and let's see what happens. And try to you can change the color, and you can have different level of opacity. Usually, what I choose is if there are many layers. For example, like if I have like 10 layers or something like that, I usually use 20% opacity, which is not very visible. However, usually it's fine to see if there is layer or not. For example, if you zoom in here, you can see slightly bit white, like you can see complete white, right? But the other road, those are not white, means there is below there is a road. So that's one way I do. And but if you don't like too transparent, then you can have a bit higher value, say 70%. Even 70% is very useful as well. It's almost transparent, not completely, but still you can see what kind of data you have below the first layer. I mean the upper layer. Okay. Now the first thing that to calculate the potential, we need to understand how to calculate the power from wind speed. If you remember the first lecture, let's go to the first lecture and let's see. let's revise it a little. Lecture, not this one, week 5. So we actually studied how to calculate the potential, wind potential, right? So if you go down a little, here is, this is called the power curve for those people who didn't attend the lecture 6. This lecture 5, this is called power curve. X-axis is wind speed and y-axis is power, actually kilowatt, not kilowatt hour, because this is the power, not energy. When we have power every single moment to which maintained for about an hour, then it becomes kilowatt hours and it becomes energy. So what this explains is when the wind speed is below 3.5 meters per second, this wind turbine will not work. It will just stop there. And then as the speed goes up, the power output goes up until 14, which is called the rated output speed, or also called the rated output power from y-axis, right? But the 14, these numbers are not fixed numbers. You don't need to remember these numbers at all. All you need to know is just how this wind turbine work, right? And then when when the speed is too fast, wind turbine stops rotating because it can actually cause mechanical failure. So it just stops. So it has a brake, but rather than having a brake, usually it can rotate. What is that? Rotate the wing so that wind just flows without making any power. And that's called cutout speed. Usually this happens in Korea. This doesn't happen much, but it happens during typhoon season, mostly. So to calculate this, first we need the area of this wind turbine. So this is called the sweep area, and then multiply this sweep area with velocity to the power of 3, and multiply with wind density as well, which has a unit, which has a which is unit is kilogram per, not square, cubic meters, kilogram per cubic meters, and then divided by 0.5. Then in the end, we will be able to calculate the power of this area. So unlike the solar photovoltaic or other systems, in case of wind system or wind potential, we should be able to know what kind of wind turbine that we are going to install to make sure to calculate the potential. So let's go to a website, Vestas. I mean, you can go to Minyang, probably yesterday or maybe this week or last week. Mingyang from China, they released that they can build 50 megawatt of a wind turbine, just 50 megawatt for a single turbine, which is huge. But their data is much more easily available in Vestas. So go to Vestas, and then probably here, and we are looking at onshore wind turbine. And there are wind turbines. Let's see one of those onshore wind turbine. There are some information, but technological evolution, and I can see there is 15 megawatt system, which is pretty huge. And then they must provide some more technical information about the system. They don't have it here. Then let's go somewhere. Probably this one, 4 megawatt platform. It's a small one. However, it must provide some information. Yes, I can see that. Let's assume that we are going to build V163. As you can see here, V163, which is 4.5 megawatts. Let me write it down somewhere. 4.5 megawatt. And let's see the brochure. And usually at the end, it has some kind of technical information, right? Here, rated power is 4.5 megawatt. And as you can see here, cut in speed is 3 meter per second, and cut out is 24 meter per second. And I don't know what cut in wind speed is, I don't know. And there is wind class, this can be useful, but we are not going to use it here. And if we go down, we can see the diameter, which is 163 meters. Means its radius is going to be 81.5 meters. Well, that's the information that we need. And then we will go back to QGIS. Now, to calculate the potential, we need to we need to make this as a cell or grid. So go to vector. So remember from this one, and then I will, for every single step, I'm going to stop about a minute. I will provide you about a minute to repeat. So at the moment, you can just follow. Go to vector and go to research tool and create grid. And we are going to create hexagon. And then what is going to be the diameter or the size of the hexagon? It is going to be 163 meters. However, can we build wind turbine for every single 163 meters, like shoulder to shoulder? Do you think so? Actually not. We need a certain amount of gap between wind turbine. Usually, that is going to be 5D, which is 5 times of diameter, or if the wind turbine is big, then it becomes 8 times of diameter, so that the turbulence of one wind turbine does not affect to the mechanical structure of the next wind turbine. So basically, to avoid any mechanical failure, we need a certain amount of a gap. So in this case, I'm going to apply about 5. So 163 meters multiplied by 5 is going to be about 900 something meters. I'm going to say just 1 kilometer. That's the easiest. Okay, so what we are assuming is we are going to build 1 turbine for every kilometer. And then we are going to run it. Before we run it, we need to specify the grid extent. So that means how much area or what kind of area you are going to use. So we are going to use the map or canvas extent, and then we can just run it. And we have this output. Slightly bit weird than we expected, because as you can see, all we need is just this area, not the entire area. But why do we have all of this? We can talk about this later, but before that, please go to your QGIS and create this hexagon with 1 kilometer size. And we'll provide you, I will wait here about a minute. And if you have any question, please let me know, or just if you have done it, you can thumb up. So when you are doing it, some of you might experience something different. For example, let's see. For example, when you try to make a research tool and create grid, rather than kilometer, some of you might see just degrees, because we have 2 different coordinate systems. One is WGS, WGS, right? Yeah, we have this kind WGS system, and we also have another system which is a basically kilometer or meter based system. So in this WGS system, that is when we use WGS system when we want to cover large area. So in this case, you don't use kilometer or meter, but use degree and degree second. And but in this, we are calculating in a very small land area. So in this case, we can use unified system which uses meters. So if you change your coordinate, base coordinate to meters, then you can go to research tool, and if you see the grid, now you can change it to, you can calculate it using kilometer or meters. Okay, so next thing what we needed to do is we need to clip the area. Let's type clip in the processing toolbox and then double click it. We are going to clip the grid using the Jeju protected step 2. Before we do it, just please bear in mind that I always confuse this which one need to come first, but I'm pretty sure this should be the one, but I don't know. Let's try to run it. And you can see no spatial index exists for input layer. Performance will be severely degraded. It means some of your data doesn't have a proper spatial index. Let's go back, and if you double click your Jeju protected step 2, and then if you go to source, you can see, oh, spatial index actually exists. Then this is not the one. Go to grid, and then you can see spatial index doesn't exist, right? Just all you need to do is just click it. You will say the spatial index was created. Say OK, and click OK. And then go to click again. I mean, even if you don't have a spatial index, it doesn't matter, actually, it calculates. However, it takes long time, much longer time compared to when you have a spatial index. So basically, spatial index is an index system for each spatial like information. So if you don't have it, then you need to, I don't know how actually the system works, but to the best of my knowledge, if you have a spatial index, it becomes much easier for this GIS system to find a the spatial information using the index rather than searching the spatial information one by one. Does it make sense? Hopefully. And then, yeah, input layer of this clip is going to be grid, and then overlay layer is going to be Jeju protected step 2. Let's run it, see what happens. This takes some time. Yes, it's been done. Let me double check if things are correct. We can see the information. I mean, we can see the grid, right? And then if we click it, we have the information here. And then seems it has a proper polygon shape as well. Let's try it the other way around. Let's rename this clip 1. And then we will click again. But this time, Jeju protected step 2 is the input layer. And overlay layer is going to be grid. Let's run it. See, this is what I wanted to share with you guys. All we did was changing the data set, the order of data set, right? The previous one took, I don't know, about maybe 10 seconds or something like that. But this one it will take about a minute or more than a minute, maybe 2 or 3 minutes, right? I'm pretty sure same thing is happening to you guys. So the reason is usually it is better to have less polygons in the input layer. It's fine to have more polygons in the overlay layer. In the case, it's faster than when you have a more polygons in input layer. Does it make sense? Like, for example, in this case, because let's cancel it, this Jeju protected area, if we click it, as you can see, this is just one polygon. This looks very complicated, but still this is just one polygon, right? However, in case of this grid, this must be a lot of polygons, right? So in this case, if it's possible and if it's fine, it's better to have Jeju protected step 2 as your input layer and then grid as your second layer. Sometimes it doesn't work. Sometimes the other way is faster, but usually that's how I work. But you should try it and try to find the better one. So when the time takes too long, do not just leave it there. Try the other way around and see what happens. Okay. So now we have the grid. Let's jump into our course. Okay, we have this clipped information. We don't need a grid, and we have clipped information. Now, what we are going to do is we are going to create a centroid. We are going to create centroid. And we'll create centroid for each part. And then we'll run it. Nothing happened. Oh, sorry. I think I did. It shouldn't be each part. I created clipped and this one. Yep. Sorry about that. Need to make a centroid for this. So let's do this on your own computer, on your own QGIS. And if you have any question, please let me know. We'll wait here for about a minute and we'll see what happens. Otherwise, I will proceed. We'll wait here 5 seconds and then we'll proceed. Okay, everyone's here now. Okay, now what we need to do is we will import the raster information. Go to your downloaded file, and you should have these two raster files already downloaded on your computer. If you didn't, you can go to the data folder, which I provide a link to our message, and download these two TIF raster files, and then drag and drop to QGIS. Let's see the information. So wind speed, these two data is basically one wind speed is wind speed at 150 meters height. And the air density is also air density at 150 meters. If we click one of the information, wind speed is 7.9, average wind speed is 7.9, and probably here 4.5. You remember that the cut-in speed was 3. And the rated output speed was about 14 or 15 or something like that. So if we build wind turbine in this area, it cannot provide at its rated power output at all. So that capacity factor is going to be very low. We can expect it. And if we build it here, probably a little higher, but still too low. What about this? 8.7, right? Still too low. So that's what is going on in South Korea. Basically, wind speed in South Korea is very low. So, and it's not the point. You can type sample on your processing toolbar, and you can see sample raster values. We can double click it, and we will sample it to centroid. And we will sample wind speed first. So we will just type wind speed. Usually I add something like this for my own purpose. You don't need to, but for example, this means meter per second. So I usually add unit, not to just to make sure that I remember, I know the unit of the data set that I'm dealing on, and run it. Then we have a sampled data set, which must have a proper value here. WS MPS1, which is wind speed of meter per second. So please do this on your QGIS. And then we will sample once again. So to sample it, we'll rename it to sampled one. We will sample twice. We'll sample it to sampled one, and then we will sample air density. I will rename it to AD. It is kilogram per, what is it, cubic meter. Now, if we click the point, then we must have wind speed and air density. Right? Okay, this is good. So I'm going to wait here 1 or 2 minutes. So please go on your QGIS. Please make this sample file for you. Okay. So you might have different language. So you can just type the sample. Must be sample in Korean. Sample raster value. I'm sure you can get it from here. Let's see. Probably not, or maybe in vector. Not in here. There's no menu for that. You need to go to processing toolbar on your right side, and then you can type sample or something else in Korean. But just for your information, QGIS is open source. So translation is not perfect. Translated by somebody. So usually it's best to use in English. If you change your QGIS to English later, you can go to probably preference, and then you can click to general and override the system locale, then change it to your own to English. Unfortunately, you don't have UK English, so real English. You don't have real English, but you have fake English, American. So you can use American English here. So how is everyone? Is it going well? Or still having difficulties in finding the menu or the tool? The other way to find it, if you cannot find on sample, you can go to I will show you. You can go to raster analysis. So you can go down to here, raster and raster analysis. Must be raster 분석 or something in Korean. And then if you open it all the way down, somewhere here, you must be able to find, yes, sample raster values. So thus, I will show you here once again. When you sample it, the input layer is your vector. So the centroid. For the first one, you need to use centroid as your input layer. And then you will sample wind speed first. Then you will have a vector called the segment. Let's do it once again. No reason to rush. So centroid and wind speed, and I rename it wind speed meter per second. Right, and then we can run it. Then rename it to sampled 1. Then we'll sample once again. This time, input layer is sampled 1, and raster layer is air density. And then name it as AD, air density, kilogram per cubic meters. And then run it. Then we have this sampled output. Okay, we have this sampled data. If we click this sampled data, and it doesn't have a spatial index. So we are going to create spatial index. You can open your own sampled data at the moment. I'm going to go through just one by one while I'm explaining it. So open your own sampled data, property of your sampled data, and then go to field. And you can see there are values. We have ID, and we have a wind speed, and we have air density, right? We can make sure that we have all of the data that we need. Now, we are going to edit by clicking this yellow pencil. We are going to toggle editing mode, and then we will delete left and top, right, bottom, row index, and column index. Those are not needed. So select all of them using Shift key. So you can select multiple if you push down your Shift, and then click the remove delete field, which is the second from the left on the top, the red one, delete it. And then if you toggle editing mode again, it will ask to save it or not. Of course, we want to save it. So in the end, we are going to have only ID and wind speed and air density. So are we all here? Please do this on your own QGIS, and please thumb up if you have done it. Thank you. Okay, now we have this sampled data. We're going to calculate actual power output. So again, let's make it as toggle. Let's make it as edit mode, and then click the field calculator. So for this process, I'm going to give you some time. So please focus on my screen and let's do this all together, and then let's see the result, and then you can work on your own. Okay. So output field, we need to change the output field to the real number. So if you have just whole number, which is integer, you are missing too much information in this case. So we need it to be real. And if you know, you can decide the precision. If you don't know, just leave it as is. However, if you can decide it, the entire size of the file is going to be smaller. But I'm going to just leave it. I'm going to type it as a potential. And then we will calculate the potential. First, multiply with 0.5. Start with 0.5, multiply with a rho, which is energy density, air density, and then multiply with a wind speed. It must be power to the 3 to make sure you need the parentheses, and then we need the area. So what was the area? The diameter was 163 meters for this machine that we are working. So it must be 81.5 meters multiplied by squared and multiplied by pi. And I think this must be the output of watt per hour. This must be a yeah, this kilogram and meter. I think I need to double check it. What is going to be the unit of this one? I always confuses it. I'm pretty sure it must be watt something, but let me double check it. Well, I will try to see. Yeah, let me double check it, but this is going to be the power output. I'll just rename it as power output. Okay, let's calculate this on your own computer. So just to make sure, I'm going to rewrite the equation for you. 0.5 multiplied by air density, and then multiplied by velocity is wind speed, and power to 3 multiplied by pi, and power to 2, which becomes the area. This is the equation, and I wrote it as a power output, I think, or something. So please do it on your own machine and calculate it. Okay, let's proceed. So now we have a power output. Now we are going to calculate just one more thing, which is potential. Now finally we have the potential. How to calculate it? Power output is, as I said, is a watt, right? So we'll divide it by million to make it to megawatt. Then we'll multiply it with 8,760 so that this becomes megawatt hour over year. So the unit of potential is going to be megawatt hour per year or per annum, whatever you prefer. So this is the potential. Please do it on your QGIS. I'm going to wait here until you do this. Now we have a potential. There is one more thing that we want to add. There are many more things we want to add, but we are going to add just one by one. Next one we want to add is going to be capacity in megawatt. What is the capacity? We already know the capacity. It was 4.5, and then it needs to be real. Make sure this is real, and it needs to be 4.5 in megawatt. Okay, please edit. I will proceed about 10 seconds later because this one is too easy. Make sure it is not integer, it must be real. Just 4.5, yes, that's correct. Now next one we need is going to be area. Doesn't need to be real this time because anyway, the value is going to be huge. If you type area in search field, you will be able to find two different areas. One is area with dollar, and another is area without dollar. What's going to be the difference? Okay, one with dollar considered base is called ellipsoidal area, so that it considers the shape of a sphere shape of the Earth, and then the one without dollar is basically spatial reference used based on spatial reference system, which calculate a plane area. In this case, area is just fine. And we needed to add something like this. Must be geometry. Probably not. I always forget this. Area with geometry. Then integer. I wonder why this is no. I don't get it. I'm worrying a little. I have a little concern why the value, preview value is no. It shouldn't be null. Everything is null here. I'm worrying a little about this. This is a bit weird. So in this case, what we can do is simply change to area. Let's see. Ah, I got it. We are working on sampled data, which is point, so that it doesn't have area here. So yeah, obviously it is null, so we don't need this one. So what we have at the moment, we have a potential, we have a capacity, right? So we can calculate capacity factor. It is going to be real number. We will calculate capacity factor first, and then we will calculate area after a couple more process. So what is the capacity? How to calculate the capacity factor is easy. Potential with megawatt hour per annum. It's easy to understand the unit of this potential, right? Because we already made it sure is megawatt hour per annum. And then divide by 8,760, and then divide by capacity per megawatt. This is a little weird because this value cannot exceed oh yeah. Yep, I missed one part. I missed just one more part. Let's add potential mechanical potential with megawatt hour per annum. So there is something that I missed from the potential plot. Okay, we need to add multiply by 0. Probably 4 is too much. 0.3 is too small. Let's say 0.4. What we missed in the previous calculation was the mechanical efficiency. So we missed mechanical efficiency completely, so that we assumed that 100% of each power from the wind speed can be converted to the output. But actually, it's not true, right? In the real world, we always have a mechanical efficiency, which is about 35 to 45% or something. So I assumed it is going to be 0.4, which is 40%. We will calculate it. Can you do this on your own computer? So potential megawatt hour per annum multiplied by 0.4. Easy. After you have it, we can calculate mechanical the capacity factor using mechanical potential underscore megawatt hour per annum divided by 8,760 divided by capacity. It seems capacity itself is very high here because usually in South Korea, capacity factor cannot go above 30%. This can explain two challenges that we are facing. One is probably mechanical efficiency seems too high. Maybe we can find mechanical efficiency somewhere here. I'm not sure if they would provide it. Mm, no, I don't think that they provide it, unfortunately. But one thing I can assume is our assumed mechanical efficiency is too high, or the wind speed itself seems too high, or maybe the lower capacity factor in South Korea was due to other issues like curtailment or something. But anyway, we can calculate the CF, which is capacity factor, and each unit is percent, right? We can calculate it. Now we have quite a few information here, quite useful information, right? But there is one more thing that we need. There are two more steps that we need to go through. So, but before we go through, I wonder if everyone is here or not. If you need some more time to follow up, I can give you a couple more minutes. Will you let me know using thumb up or down? Okay, then I will just proceed. So what we are going to do is at the moment, our data is all in just point. Then what's the point of doing all those a difference and union and everything? Because we needed to move those points to our clipped grid. For that, we will use join attribute by field value. I don't know what this join attribute by field value in Korean, but you can go to vector general and then you can find join attribute by field. Probably you can see it here. I don't know. Probably this is not the one. You can find it here. No. So you need to find it from toolbox. You can go to vector general and try to see something similar to join attribute by field value. Okay. Double click it. I will give you some more time after I show you how and what to do. So please just follow my instruction at the moment. You can just see my computer. And then if you have a question later, you can ask. Input layer is going to be the clipped one. And that input layer 2 is going to be the sampled. There is one interesting table field. We have ID, right? The reason that we created centroid rather than make completely independent point-based grid is because we wanted to use this a join attribute by field value function later, which is now. So using this way, each ID field is unique value. So clipped one has a unique ID and sampled has unique ID, but because this sampled is basically a centroid of this clipped one, their ID is exactly the same by the location. So we can use ID to combine or to join two different data sets into the input layer. And what data do we want to move is we want to move all of those calculated data. Click OK. And then we will run it. Then we will have this joined layer. If we click it, as you can see, we have all the data that we needed. Right? Okay, I'm going to wait here maybe 1 minute or two, 1 or 2 minutes. So please proceed on your QGIS and please thumb up when you finish this process. And if you have a question, please let me know. You know, okay, you can go to field value and then input layer is going to be, yep, input layer is going to be, where is it? The clipped one, which is clipped hexagon grid. And then the second input layer is going to be the sampled, which has all the information we calculated just before. I'm going to stop here 10 seconds, so do it on your own computer. And then table field for both is ID. And you can see layer 2 field copy. You can find these three dots, click it, and then choose all except ID to copy. That's it. And then run it. I will just leave my screen as is for a while. Okay, great. Now, let's jump into this joined layer. Let's double click it to see the properties. We have lots of information. Again, toggle it and remove those four. And we don't need a row index and we don't need a column index. All we need is just this. And also, I don't like this name, so remove one in the end. So this is how things would look like for me. It's fine if it looks different in your computer, in your QGIS, it's totally fine. But I tend to remove unnecessary data whenever I see them. Otherwise, in the end, you are going to have a huge file with a bunch of trash data set. So then go to field calculator. I'm going to create area, finally. we will calculate plane area of this geometry. I wonder what's the difference. Probably the same. I always use dollar, not add. So let's create area with a geometry. And then click OK. And then go OK. And if we find one of the grid which has never been cut off, almost perfectly which has almost perfect shape, like this one. There is one. Like this one. If we click it, we can see each area is 866025. Is that true? Derived area is 866025, right? Cartesian area is 866025, right? That's the area. The reason that we created this is because we want to extract, must be extract by attribute or expression. We're gonna extract by expression. Does it work with attribute? Let me double check it. Should be fine with attribute. So we are going to use extract by attribute. We'll choose join the layer. I'm going to show you how to do it, and I will give you enough time to do it. Join the layer, and we'll select area, and operator should be equal or more than say 700K. The reason that we are doing this process is because in case of wind power, you need enough land area around to make sure that it's safe when it falls or when there is an accident, right? But unfortunately, using QGIS, it is very difficult to like say wind turbine is going to be at the center, make sure there is no like houses or anything around like certain meters of this point. Calculating those kind of thing is a bit more complicated. Of course, you can do it using buffer and some more complicated functions. However, that's not the point what we want to do at the moment. So we are going to assume that if the area is more than 700K square meters, that it is safe to assume that we can install wind turbine. Okay, so please do this, and then we can run it, and then we have this extracted area. So the last step that we are going to go is go to layer, no, sorry, view, and go all the way down to panel, and then open statistics. Then you will see these statistics. Please thumb up if you have the statistics layer on your screen. Okay, then choose join the layer. Choose this join the layer, and then we'll choose potential megawatt hour per annum. We can see that this area had the average potential of this area is about 40 gigawatt hour, and then each total potential is going to be 14749. How much is it? I think it's about 15 terawatt hour of potential. What we just calculated here is the pretty much technical potential of wind turbine or wind farms. This is not economically available feasible potential. For example, those area where which created only 22 gigawatt hour will have a capacity factor less than 20. In this case, I mean, this is very, how do I say, very aggressive number at the moment. Our calculation is very positive numbers. So if you use real world numbers, all the values will be much lower, which means even if we achieve maximum potential over grid, still each output is going to be lower than this calculation. Actual output, real output is going to be lower than this calculation. So that many of those values should be removed. So for example, we can do this once again using I extract, and then you can calculate, we can choose those potential with a higher than say 50 gigawatt hour per annum. Then we can have another potential. And those are the area where we have enough solar, enough wind resources to build to economically enough. Those are the areas where we can have enough wind resources to build wind turbines. Okay, I think that's it. And if you have any question, please let me know. I'm going to check the message. Please let me know. And this is it, I think. Yeah, fantastic. This is it. This is the end of our entire 8 weeks class. And for me, this is the end of 24 weeks class in 2025. And it's been my honor to provide what I know to you guys, to share what I know. I hope this is valuable to you guys in one way or another. And if you have any question on Python or modeling or data analysis or QGIS or whatsoever, you can just contact me. Yeah, do not hesitate. Just drop an email. I'll be more than happy to answer whatever you want to know. If I know, or if I don't know, I will try to find somebody who might be able to solve your problem. Okay,